How's it going, everybody? So today we're going to continue on talking about the Industrial Revolution. We're actually going to talk about the specific technological advances because remember the theme of the Industrial Revolution is this stuff that is not powered by man. Okay, and so what are the materials? What do we need? What's going on here? So let's get right into it. And of course, the steam engine is really going to be the driver, if you will, of this. Okay, that is kind of one of the coolest looking trains I've ever seen in my entire life, and we'll get to that with the steam engine. And the guy that is primarily responsible for the steam engine that would be massively used, if you will, even though I don't think that's a word, but that's okay, is James Watt. And again, James Watt is so important, he gets his own title slide. He is going to be the primary developer of the best steam engine, but quickly, I'd like to give that a shot to Thomas Newcomen. Thomas Newcomen does not get really the credit that he deserves. He did create really the first functional steam engine of this era because there is some evidence that Hero of Alexandria, like 1800 years before this, like came up with something, but we'll get to that at a different time. And he created a steam engine that basically powered a pump that got water out of mines, which was really important because mining was important, but it was fairly inefficient and not super great, and so he doesn't really get the credit that he deserves, but he gets it from me. All right, so why was Watt so important? One, I just love, the story, and I don't know how true it is, but you see the picture on the left there that when he was young and just like a British lad, they loved their tea, and he was looking at the teapot as it was boiling the water, and the little flap on the teapot started getting pushed up by steam, as you see him here, kind of touching that, and that kind of came with him this idea of what if we use that to, if it can push this little thing up, what else could it push, and that eventually allowed him to get into, engineering, if you will. The key thing for him was that he took the ideas from Newcomen and others, and he made a wonderfully efficient a steam engine that you didn't have wasted motion, and basically the idea of how a steam engine works is that you would burn coal, okay, and that would heat water, and that would turn into steam, and that could push pistons and all sorts of stuff. And what's great about his invention specifically is not only was it efficient, it was incredibly powerful. Basically, all you had to do is that the bigger you could build the engine, the bigger the stuff that you could pull or push or drive. That really it's the same type of engine, just larger. So eventually you'll have steam engines on boats, like for instance a lot of the World War II vessels were steam powered, okay, to give you an idea of how long this lasts, early 1800s to the mid 1900s. And it was very versatile, okay. I mean, steam engines will be used on trains, they will be used for factory equipment, they will be used for heating equipment, they will be used for steamboats and eventually giant, giant warships, and that is what is so crucial about Watt, and he's so important. He has a unit of power named after him, so he's crucial there. But that was like, this is the invention that sets everything apart, and then everything kind of spans upon that, and then eventually we'll get another engine in the very late 1800s. That's the internal combustion engine, and that will be really important, and we'll talk about Nicholas Augustus Otto and that later on, but this was the vital moment here. Okay, now, along with that, we need something that we can make everything out of, and that is going to be iron. Now, look, iron had existed for thousands of years before this point, right? But there was a problem with iron. Even though it was very heavy and quote-unquote strong, okay, it had a lot of impurities in it, basically on the way that they made it, okay? So the iron at that time was known as pig iron, and it wasn't particularly good because it would rust over time, and it could be very brittle, and you can only build things so big with it, right? Well, in the early 1800s, what we're going to get happen here is a guy by the name of Henry Cort is going to develop a process that can take more and more impurities out of the iron. okay, and it makes it more malleable, so you can shape it into different things. It makes it much more durable, and the process of that is called the puddling process, okay? Basically, the iron has to be put in, like, basically these large puddles, and then they do all sorts of stuff to it that I'm not going to get in here, and the iron that you get out of that is called wrought iron, okay, or puddled iron, and with that, you can do anything. As you can see on the picture of the right, that is the Eiffel Tower, the fact that we could build things that big. Okay, and when the Eiffel Tower was built in the 1800s, it was the largest building in the world. Okay, or not the largest, the tallest. By the way, taking over for the Great Pyramid of Khufu, to give you an idea of how old that thing was. So that was like the largest building on the world for like 4,000 years, and then finally the Eiffel Tower gets it. So go Egypt there. But this is what is also going to enable us to eventually build skyscrapers and steel ships, and so iron and steel, and it's just all over the place. And so it's really crucial. Something else that we will use this iron for will be railroads. Now, the first railroads basically, or the idea of railroads started with in mining, okay? And they would build these rails so you could push mine cars, if you will, back and forth. You were doing it with human power. Sometimes you would use a horse or something like that. But the idea was that, well, wait a minute, what if we created an engine, or a locomotive, as it would be known as, that could drive it? And a guy by the name of Richard Trevithick, or Trevithick, maybe? He's the guy on the left there pointing to, I don't know, maybe a railroad behind him. I don't really get the picture, but whatever. And in 1804, he really develops the first steam-powered locomotive. You see part of it right there. Other locomotives would look similar as they go on. And basically, it's one big chamber here. Okay, but George Stephenson is the guy that really revolutionizes it. Here's a painting of him. Here's a picture of George Stephenson with his rocket. This is one of the original ones in a museum today. And the rocket was incredibly powerful. It could go 16 miles an hour, which at the time was insane. Okay, understand that, everything else is much, much slower. Okay, and the cool thing here is that this train would be so powerful, and guys, they'll just make it bigger and bigger and bigger, is that these trains can move people and goods, particularly goods. So now we can get things from market to market, and because with railroads it's going to be cheaper to move the stuff, that stuff can be less expensive. It's just going to be fantastic. And so look at it this way. 1830, the rocket is introduced. Okay, and by 1850, in Great Britain, they had laid down 6,000 miles of railroads. To give an idea of how much that is, okay, Britain itself is only 386, or sorry, not 300, it's 874 miles long and about 300 miles wide at its widest point. Most areas are much less than that. So in an area that's only 874 miles by 300 miles at its widest, they laid 6,000 miles of track. And of course, now we have the steam engine with this. Now the coal industry goes just absolutely bonkers, and it's all about mining for coal. Now, so again, what is the big deal of this? One, it gives us Thomas the Train, which is, important. But, we keep pushing and pushing. So now we have trains, and then eventually we're going to get steamboats. Okay, which are going to even be better than regular boats. Now, steamboat invented by an American, that's George Fulton, and they were primarily used to travel up and down the Mississippi River, and then we will get larger and larger. Of course, at one point you got like the Titanic, which is a steamboat, and as I said, some of our large U.S. warships all the way up to World War II would be steam-powered as well. Okay, and it's absolutely incredible. I mean, it's absolutely incredible, all the different things that you can do, all right? And so we've got these large things, these steamboats that can move around people and goods, and railroads that can move people and goods. And then we're also going to be able to, get factories going, okay? Because the smaller machines that I talked about in the previous PowerPoint, or the previous presentation, like the stuff created by by Hargreaves and Crompton, that is going to be steam powered as well. And this, by the way, this eventually, all the steam power eventually will also go into electrical. So we'll talk about the importance of electrical stuff later, you know, Edison and his crew and Tesla with all the stuff that they do. But like now you have all of these extra things that are powered that we're now going to develop the full-blown factory system. I said we kind of introduced it by putting people in one spot, but now we're really going to change it here, okay? So the whole idea is that this is a new discipline. This is very different, that you are going to wake up at a certain time, you're going to go work for a certain time, and then you're going to go home. I don't really like that idea. Wouldn't mind a little bit more freedom, I'm not going to lie, but what can you do? And that is the idea of shift work, that you're going to work specified times during the day and during the week. Most of it is at least 6 days a week, if not 7. Okay, you are going to be giving a specific job, and those jobs are all about efficiency and using these machines and these big cotton mills. And so all the machines that you saw, they're just getting bigger and stronger, and they're run by steam power, okay? The advantage, however, is all for the owners, though, okay? Because now what's happening is that the owners own all the means of production, okay? And so that's going to allow them a certain amount of power. And as you see there on the left, the aim was to such machines of the men as cannot err. What does that mean? The idea is that they're going to make people into machines. That's the whole idea. Okay, and so this is all the technological advancement that we've got going on. You're going to get just this massive expansion of economic activity, and we're going to talk all about that type of stuff. And there are going to be some issues in the future that we lead to, you know, health issues and stuff like that. But, you know, the modern world is really taking shape in and around these inventions, okay? Inventions and innovations. All right, guys, well, I will see you soon, and we'll get to our next video.